Hello, it's Mr. Upstart, and we're going to work through a binomial distribution example. So take a moment, read the question, we'll see what's going on. And so I know I have a multiple choice test of 10 questions, and each question has 5 answers. Only one of the answers is correct. For each question, Jose randomly chooses one of the 5 answers. Okay, so if we think about this question, we have to think about our conditions for binomial. And so the first one I want to say, is there a success-fail condition? Well, I either get the question right or I get the question wrong. So this one is good. The second one is the probability from trial to trial. Is it the same each time? Well, if he's randomly choosing one of 5, which is 20%, it doesn't matter which one he does, so it is independent that the probability stays the same. So that's good. And then finally, is there a fixed number of trials? Well, there are 10 questions in total, and so that's how many trials there are. There's 10 in total, and so we are set there. So all the conditions are met. So we want to find the probability that Jose answers exact 3 questions. Before we can do that, though, we have to introduce our random variable, and let's say that x is a binomial with n. Well, this is n and p. Well, my n, I know already, is going to be 10. And my p, the probability of success, is 20%, so 0.2. Okay, so A part now says we want to find the probability that Jose got exactly 3 questions correct. Well, I've introduced the binomial, so I want to find the probability that x equals 2. Okay, and then I go to my calculator and I'm going to go to distributions, this blue there, so second distributions, and I'm looking for the binomial one. And experience has told me it's quicker to go up, and I want a specific one. I don't want to accumulate, I want a specific one. So the probability, the PDF, and I know there's 10 trials. I know P is 0.2, and I'm looking for exactly 2. And my answer is 0.302. And this is all I have to write to get full credit. But I have to introduce the variable, and this is sufficient. The calculator will do the work for me. B part says, if the probability that Jose answers more than 3 questions correctly. Well, I'm going to do a little bit of thinking here. If I have 10 questions, that means I could have 0 right, or 1 correct, or 2 correct, or 3 correct, or 4, or 5, or 6, or 7, or 8, or 9, or 10. I can have, these are all my correct. More than 3. Well, more than 3 means 4 and higher. I want all these probabilities. I want to find the probability of exactly 4 plus probability of 5. So it means I want to find the probability that x is bigger than or equal to 4. Well, all of these probabilities, if I have the probabilities, if I add them up, they will equal to 1. So if I can find this probability, subtract 1, I will get this part here. And so this is the same. The reason why I'm saying that is because when I use my calculator, I have a scenario called Binomial Pdf. And this is cumulative. But the way the calculator works, it always starts at 0 and goes up to a value. It always starts from 0. So I can't magically start in the middle. So another way to conceive this scenario is I want bigger than or equal to 4. Well, I can say 1 minus the probability that x being less than or equal to 3. There's the same thing. So if I now go to my calculator and do Binomial Pdf and do my trials as 10, my success is 0.2. My value, I want to go all the way up to and including 3. And then I'm going to, I know this is backwards, so it would be negative, so I'm going to subtract 1. And so it's going to be 0.121. it should be 1 minus this, so it's just going to be the positive of that value. And so this is my B part. This kind of a diagram always helps me keep track of what I'm trying to find. It's just kind of like my sketch, my rough work. And finally, C part says, if passing a test means you got 50% or more correct. So 50% for 10 questions means 5 questions. Jose tells his friend he passed the test. Determine the probability that he got a 70%. Okay, so this here, I know already he's passed the test. So I want to find the probability that Jose got 7 correct, which is 70%, given that x is bigger than or equal to 5. Okay, and so now we have to think about this. We want to do conditional probability, which is going to be the probability of x equaling 7 and x bigger than or equal to 5 over the probability of x bigger than or equal to 5. Well, if I go back to here, bigger than 5 means I'm going to consider all these numbers only. I want the intersection of bigger than 5 and of 7. Well, it's only the probability of 7. And so it's going to be the probability of 7 over the probability that x is bigger than or equal to 5. And so using my calculator, I know I can't do bigger than 5. I can only do less, starting from 0 up to 5. So I'm going to do, this is the probability of x equal to 7 over 1 minus the probability of x being less than or equal to 4. And this thinking here, it is really important that you do this kind of thinking, because this is the communication part, right? This is like the algebra of probability of going on here. And so now I can just go to my calculator, plug this all in. I'm going to go to the Binomial Pdf. And I'm going to go 10, 0.2, and 7. I'm going to paste that in. And I'm going to divide it by, open parenthesis, 1 minus the probability of, I'm going to go to cumulative now. The cumulative, where there's 10, there's 0.2, and x value is 4. And so now that probability is 0.239. If this is around 3 significant figures, it's really, oh, I messed my zeros up, so let's try this again. It's going to be 0.0240. Okay, and so we know that binomial probability is a really helpful thing. Use this kind of thinking tool here to help make sure you know which probabilities you're adding. And the calculator always starts at 0 and works its way up for cumulative.